Hello, everyone. Welcome to the first talk in this track for the morning in Cockle Bay. First up, we have Benno Rice talking about the new COBOL.
Hello. So when I saw that the announcement that Vicky was going to be keynoting, I thought to myself, pity the poor fool who has to go on after her. Anyway, so I am here as a nerd because languages are fascinating. Programming languages are fascinating to nerds. But nerdery is a state of mind, I think. Like, everyone is nerdy about something, because I define nerdery as like, you know, having a very deep and loving knowledge of a particular subject to the point where you could conceivably bore someone to death with it if you chose to. But programming language nerds are an interesting breed, and you know, I came up at a time when there was a lot of language comparisons going on, there still are, and one of the topics that inevitably comes up is languages that suck. And my talk here, I think I'm lucky in that I've ended up at kind of a nexus of Oren's keynote and Vicky's keynote, and we'll get to that. But you know, suckiness has several axes. Languages can suck for several different reasons. And you know, the most obvious is that things have been designed to, but you know, we'll get to that in a sec. But one of the big things that used to come up, and we're talking like the late 90s, early 2000s here, is which language is the new COBOL? And so, has anyone here actually written COBOL? Excellent. In anger or just for the fun of it? Oh, and the thing is that this whole question of what is the new COBOL casts COBOL in a specific sort of context. And the usual context is languages that are dead or a joke. And the thing is that neither of those are really true about COBOL. I mean, whether a language is dead or not is a whole interesting concept in and of itself, because like Adam, I think I've coded in at least 2 or 3 or 4 of those, 5, and I don't think assembly is going away anytime soon, even if people aren't writing it directly, but some of them are. And then as for jokes, I mean, whether a language is a joke or not is an equally subjective thing. I mean, there are languages that are actually designed as jokes. Wikipedia has a lovely page of them. There are some wonderful examples. This is the language with no pronounceable acronym, or intercal. It's a very early joke language. It was designed explicitly as a joke. Everything is done pretty much the opposite of what you would expect. The read out instruction at the bottom writes a letter to the standard output. If you want to read in, you say write in. Instead of go to, it had come from, which led to an implementation of threads using multiple come froms from the same location. And to end a program, you say give up, or more idiomatically, please give up. The please doesn't do anything, but if you didn't put enough of them in, the compiler would refuse to compile your program because you weren't being polite. And if you had too many of them, it would refuse to compile it because you were being obsequious. That's not the only joke language. This is a language that I shall refer to as brain fork. It has 8 opcodes, all of them are single characters. That is hello world. All of these examples are hello world. If that's too readable for you, this is Malbolge. It's a ternary machine language. The opcodes are still single characters, but they change function based on where they are and self-modify. If one dimension is not sufficient for you, then Bfunge works in 2 dimensions. The control flow is in 2 dimensions, and the angle brackets, V's and carets change the way the control flow is going. And if you prefer something a bit more along the lines of Bianca's talk with Rockstar last night, there are plenty of languages that work on those lines. This one's based on My Little Pony Friendship is Magic. And then there are languages that are not designed as jokes, but can seem like jokes if you look at them wrong. This is not Hello World. This is an n-dimensional Sudoku solver in APL. This is the more readable version. The original version that I saw was in Rommel's talk at North Bay Python, and it was a lot harder to read, but it does actually solve any dimension Sudoku. And then you get to languages that people consider jokes, like language that some of us may have started with, like BASIC, or more idiomatic BASIC. And the thing is, you know, these languages are people, like my first code was written in BASIC, so, you know, I can hang shit on it a bit but, you know, it's where I came from. And there are other people who started with other languages that people also, you know, don't give grief to these days, like Perl. or Ruby, or Python. Sorry, Python. And the thing is, languages have a really rich and long history. This is a sort of a genealogy chart of languages that goes back all the way to the beginning of programming languages as we know it. It's a bit hard to read in this form, but we'll zoom in on it in a sec. You can find it at the URL at the bottom there. And so if we zoom in on this a bit, we can see Python over here. We can follow Python 3 back to where it splits off from Python 2. And then we can follow that back all the way to the very beginning of Python, and we can see that Python was kind of derived from 3 different languages, being Modular 3, ABC, and our dear old friend C. But the interesting thing about those languages is if you follow their lineage back, you get back to ALGOL. ALGOL, or algorithmic language, was one of a set of 4 early languages that kind of really set the stage for the way we see programming languages today. ALGOL was kind of the computer science language, but there were 3 other languages that we'll go into here. One of them is FORTRAN, which is probably the earliest language that really shown up. FORTRAN was the mathematics language. It was used for numerical analysis, a whole bunch of things. And this quote from John Backus is interesting. Backus is the Backus in Backus Nair form, if you didn't know that. Much of my work has come from being lazy. I didn't like writing programs, and so when I was working on the IBM 701, writing programs for computing missile trajectories, I started work on a programming system to make it easy to write programs. The thing that jumps out at me about this is it echoes a whole bunch of things that Larry Wall says a whole lot of time later about Perl. And the thing is that FORTRAN has an impact on a lot of people in this room because it shows up in places like NumPy. NumPy is numerical analysis stuff for Python, and a lot of the code that underlies that is not written in Python. It comes from other languages. For example, BLAS and LAPACK. BLAS, or basic linear algebra subprograms, and LAPACK, or linear algebra package, are code for doing linear algebra. And BLAS was originally written in FORTRAN. There are now implementations of the same API in languages like C, but LAPACK is still written in FORTRAN 90. And then there's F2Py. F2Py is a tool that's entirely designed for you to glue your old FORTRAN code into your new Python code. And so one could almost argue that the whole rise of Python in the scientific and numerical communities is all about the fact that you could uplift your old FORTRAN code and use it within Python. So that's FORTRAN. Another really early language is Lisp. Lisp is a bit harder to categorize. It was kind of the really serious computer science language. It kind of had a niche in artificial intelligence for a while. It's really popular amongst a certain kind of person who wants a very kind of philosophical mathematical rigor to their programming. And if that doesn't make any sense, then what I suggest you do is go out in any kind of computer conference and loudly state that you don't know what lambda calculus is, and someone will come and tell you at length. But Lisp still shows up in a bunch of places. One of the most popular ones these days is Clojure. There's a bunch of Clojure code that gets written. That's fine. The other place that people use it is in text editors. That's all cool. So Lisp, and then we come to the common business-oriented language, COBOL. So COBOL starts, as you can see just before that, with a language called FLOW-MATIC. And FLOW-MATIC was the brainchild of this amazing person here. This is Rear Admiral Grace Hopper. Grace Hopper is famous for a bunch of things. One of them was actually creating compilers before people actually believed that compilers were useful. I had a running compiler and nobody would touch it. They told me computers could only do arithmetic. And also, the idea that she had sort of progresses further. Manipulating symbols was fine for mathematicians, but it was no good for data processors who were not symbol manipulators. And it's much easier for most people to write an English statement than it is to use symbols. So I decided data processors, this is people processing data as opposed to CPUs, ought to be able to write their programs in English and the computers would translate them into machine code. Again, this sounds a lot like what Larry Wall said. It is nice to be able to program in a set of concepts that are familiar to you and that allow you to get things done easily. So the Pentagon kind of bought into some of these ideas. And so they started saying, okay, we need a language to be able to write business programs in. Because let's face it, a large part of a modern military is making sure that material and people and things get from here to there, are acquired, purchased, tracked, dealt with, whatever. There's a lot of that stuff going on. So the Committee on Data Systems Languages, or CODASYL, was put together in about 1959 to look at what would work as a programming language for businesses. And the primary contenders that went into that were Grace Hopper's FLOW-MATIC and a language out of IBM called COMTRAN. And being committee, they shoved bits of them together and came out with COBOL. And COBOL has been around ever since. It got a major revamp in 1985, gaining things like object orientation, free-form code, more on that in a bit, and it even got XML processing capabilities in 2014. So it's still a live spec. I mean, FORTRAN's most recent spec was 2018, so these languages that are considered dead, they're still around. So that's kind of the history of COBOL. What did it look like? Well, that's 1970s era COBOL, designed to run on an emulated S390 running on Linux. Each of these lines would have been on a punch card back in the day. So punch card, bit of cardboard, holes in it so that you can read it, so that the computer can read it, and lines on the top, and line numbers so that when you drop them all over the floor, you've got a chance to get them all back in the right order. So these bits here are job control language that tells the mainframe how to link the program together so that it can run. These days that ends up, it's still stuff like that around, but it's hidden inside your executable file, and we call it shared library linkages these days. COBOL separates its programs into divisions. The identification division at the top identifies the program. Environment division tells it things about what files and stuff that it's using. The data division defines any variables or data structures that it's using. And the procedure division actually does the work. And so again, this is hello world. And when you ran this on the emulator, you got a bunch of output. Again, this would have been output probably on a line printer. So that old folded paper thing where you had the sprocket holes in the side and everything. It's great for making banners. And again, eventually it prints hello world along with a whole bunch of other informational things. And the thing is that this all looks a bit weird given where we come from. But the thing is that this all makes sense when you think about computers. Not these computers, or these computers, or even these computers, these computers. This is an IBM 701. So all of those boxes together make the computer. You feed the punch cards into it through a punch card reading machine. This was better than the old version where you had to toggle switches and press buttons to get data into memory to run your program. You print things out on your line printer, which is again better than reading lights on the front of the machine. And if you need to store things for a long time, you've got tape. Hard drives show up later and cost a lot of money. But the things that we're dealing with here are often record-oriented data, as in, each line of data is a record. And that makes a lot of sense when you think that CODASYL actually has two claims to fame. One is COBOL. The other is a body of work that lends to a thing that we now call SQL. And the other thing that computers did a lot more at the time is batch processing. You don't have long-running tasks. You have, I'm going to process all of the account transfers for today and generate some numbers that are then we're going to move around between accounts. We're going to do a whole bunch of other things like that. We're not dealing with long-running jobs. We're dealing with batch jobs that run on a, say, daily basis, weekly basis. The data gets fed in, other data comes out, things move on. And this is where you see a lot of the industries that this ended up in are things that have that kind of data. Banks, insurance companies, government departments, airlines, anything that you see where they have that weird kind of terminal-looking interface on the computer they've got, even if they've got some modern PC, they've got some window with a terminal thing in it, that's generally talking to a system like this in the back. So let's have a quick look at actually, some more sort of details of COBOL, the actual language itself. This is more modern COBOL. This is free form, so the line structure gets to be a little bit more thing. I don't have the line numbers on it. We have an identification division. This is designed to do a really sort of silly funds transfer kind of thing, just to give you an idea of what it looks like. We have an environment division that defines a file that we're using. You can define different organizations. You can have indexed files if you want. This is just line sequential because it works. We're defining a record structure. Each of these lines here, the line numbers at the start of the lines, the O1 and O2, define the hierarchy of the record. The pic statement or picture statement defines what the data actually looks like. So the from account and to account are 9-digit numbers. 9 means a digit, X means a character, and the bracket 9 means 9 of them. And then the amount is 4 digits and then 2 digits. So I can never transfer more than about $10,000, well, just under $10,000. We can also define a working storage section. These are what we would now call global variables. And the other thing that's here is a level 88 variable. COBOL does have a bunch of quirks that make it a bit interesting to work with, and one of them is that these level numbers, some of them have special meanings. 88s are booleans that are true when the value of the thing that they are contained within matches one of the values that you tell it. So done is when should continue is Q. And the main procedure is relatively straightforward. We open our transfer file, we perform a subroutine until we're done, and then we close it and we're done. And get transfer details just displays a bunch of prompts, accepts some data, and writes it out. And that's all pretty cool, but later on we do get things like the screen handling stuff. And one of the things that I found interesting researching COBOL is around the 2002 spec, they formalized a whole bunch of things that had been in various sort of vendor-specific versions of COBOL for a long time. And you got screen sections in the data division. So this allows me to rewrite my thing to have basically a form on the screen. I can lay out some stuff on the screen with input fields. I can define where they go in terms of the record structure. So you can see that I am getting my from input to from account, various things like that. And it simplifies my get transfer details significantly. And when I run this, because there are compilers, you can actually write your own COBOL code and run it, I can actually come up with transfer screens that look like this. And if you were in a bank or an airline check-in queue or whatever, and you leaned over the shoulder of the person who was typing it in, you would see something like this before security kind of took you away. And what struck me when I was going through all this is like, you know, we've got this lovely tool for dealing with record-oriented data and making easy interfaces on it, and I don't know anything else that does anything like that in modern work. Like record-oriented data, easily dealt with, views, forms, the whole idea that went into that, they're still there, they're just not used the same way. But that's not to say everything's perfect. I mean, this whole picture thing is important because it limits what you can express. You know, if I define things like this, I can't go above certain precisions. If I set a certain width on my surname field, then Mr. Neugebauer would like a word with me. And it's a good thing that these days we don't run into like fixed width record limits. Anyone who's reading that will notice that the tags are not saving because the tag table hit a scaling limit of the 2 billion tag mark. Anyone who knows anything about 32-bit integers knows what's coming next. 5 whys analysis. Why did tags stop working? Tag ID hit a limit. Why did it hit a limit? It was an int column. Why was it an int? I am a careless and don't follow through enough. Why am I so careless? Lonely childhood, 8 paint chips. Why am I so lonely? Vast empty universe, no God. But, so 32-bit integers, we still hit all of these limits. All of these things that are annoying about COBOL still exist. And some of the things that we think are quirky were actually things that we've then re-implemented in other languages. So why is COBOL held in such withering contempt? This is an entry from the Internet Jargon file, which is a collection of internet humor maintained by someone. So yeah, it says that COBOL is a weak, verbose, and flabby language used by code grinders to do boring, mindless things on dinosaur mainframes. This is not useful. I mean, and I'm at this point wondering where all of this contempt comes from. And I think Wikipedia has the answer. The COBOL community has always been isolated from the computer science community. No academic computer scientist participated in the design of COBOL. All of those on the committee came from commerce or government. They weren't the cool kids. Computer scientists at the time were more interested in fields like numerical analysis, FORTRAN, physics and system programming, than commercial file processing problems which COBOL development tackled. They weren't the cool problems. And so you have this sort of spectrum of cool to uncool, and those 4 foundational languages kind of fell on a fairly fixed positions in those. So, you know, you had ALGOL, which was the computer science language. You had FORTRAN, which was the maths language. You had Lisp, which was the serious computer science language. And COBOL, which was the business language. And the usual contempt stuff that Oren talked about the other day all came into play. And the thing is, you see that reflected today too. Lots of work got done in Visual Basic. Visual Basic is not regarded as a cool language. PHP, we would not have Wikipedia without PHP, but it's not a cool language. Perl was, at the time, a very cool language, but over time has lost some of its luster. But it's still very important in terms of the history of the internet, and there are still things we can learn from it today. Java. There's tons of Java code out there. I mean, there are billions of lines of COBOL still running out there, and there will be probably billions of lines of Java out there still running in 5 or 10 years' time. But it's not considered a cool language. The virtual machine might be considered cool, but Java's not. With a Python 2. I mean, there's a lot of Python 2 out there. A whole bunch of us are probably maintaining some of it. But it's not considered cool as much anymore. And so it's interesting to think about in 5 or 10 years' time, where's Python 3 going to be? But I think when I was going through this sort of thought process, the programming environment that I thought was most interesting to throw into this was Excel. The amount of Excel sort of macro work and stuff like that that goes into making sure that things like, boring shit like making sure we get paid is just staggering. And by being paid, I mean that quite literally. When I first moved to Seattle several years ago, before I got my social security number, the way that I got paid was that I had to get emailed an Excel spreadsheet with macros in it so that I could approve my manual paycheck. And it then got forwarded to my boss, who then had to approve the thing through the same Excel macro-based workflow. So it literally got me paid. And so I started thinking, when we think about when you're looking for something like what the new COBOL is, like where should we be directing this kind of, I don't know what the right word is, but what should we be looking at for the things that are making our lives miserable when it comes to programming? Maybe it's not the language. Maybe it's something else. And so I started looking at the other things that COBOL has left for us. And the obvious one, given the picture statements I was giving you before, was Y2K. The thing is, Y2K was like 1998, 99 was a great time to know COBOL. Because there was lots and lots of work going around at, oh God, we need to fix this now prices. Because everyone who had given themselves a 2-digit year field needed either a windowing function or to fix a large amount of data very quickly. And it's worth thinking about, like, surely people realized before 98, 99 that this was going to be a problem, or did they? Because there are other things. It's not just COBOL. Heartbleed was hilarious from the outside. For those who weren't paying attention at the time, Heartbleed was a major flaw in OpenSSL. OpenSSL is this little unknown piece of software that basically secures almost all of your communications on the internet. Somebody found a way to do nasty things with it, and suddenly some people discovered it was important to maintain OpenSSL. Like, we needed, because at the time I think there was, what, one person working on it? Two people working on it. And it's another things too. Event Stream was a Node.js module where the maintainer had written the module. It had gotten massive use, but the maintainer wasn't interested anymore. And so when someone came along and said, hey, would you like me to maintain that module for you? He went, sure, handed it over, and the person promptly put stuff in there to steal cryptocurrency wallets from people who used the module. Again, hilarious. And it's not just Node.js and the others, though. I mean, I think Vicky put this tweet up. Python has a maintainership problem as well, and it's not just in pip. I mean, I work for Yubico. We have a vested interest in making sure that cryptography keeps working, and so when we see things like this is a bit worrying. And so it occurred to me that, the problem with COBOL was that there was all this legacy code lying around that no one really wanted to touch. There's all this stuff here where this vital code that we rely on doesn't get looked after. Maybe the real COBOL is the maintenance debt we incurred along the way. And and so realistically, I think to avoid falling into these situations again, there is one simple strategy. support the people maintaining the code that we rely on, which is a problem in a world with corporations in it, because corporations love externalities, which is where you find something you don't have to pay for and don't pay for it. But I feel that for those of us who work for corporations, who have resources, who have money, who have employee time, who have a whole bunch of things, it's worth going to our bosses, the people in charge, and saying things like, start a conversation like, you have an unmitigated risk due to a dependency on potentially unmaintained code. And start a conversation about maintaining the software that your company relies on, whether it's internal code or external code. Because, as Oren said, speaking the language of business is important, and it shouldn't be a thing that we see as dirty or contempt-worthy. So thank you. If you have questions, I will be outside. Thank you.